Okay, so what are we doing? Guess we'll have a little picture to start with. Put that to the side. So, we've had, I guess, a full presentation while we talk about this. So I've had QSpy work in the past, not with this current iteration of hardware, and I want to get the full QSpy functionality of being able to erase, write, and verify that we wrote a block correctly. I've had issues in the QSpy not being as reliable, and I think I've gone through and fixed those issues that should be good to go. So now, the process of during this live stream, we'll see how far we can get. We want to do basically an erase, a write, and a read. Right. So we already have a read. We want to be able to read as much as we can, and we're going to look at our previous designs to see what that means. Okay, so exit out of that. That to the side. So currently we're reading where you can read the QSpy of each device. If we go to our software, we are reading the ID, Flash Info 21, and if we go to our software, Flash 21 is talking about the sector erase. How much are we erasing? And if it's 8, we're doing 64K, and if it's 9, we're doing 256K. That's how much we have to write. So we're going to go look at some legacy of our last configuration. Load bits, bring on system. Which one was it? This one? Read ID, device info read, write for flash not busy, status clear, write enable, program, page program write, and random read, erase sector, write sector, verify sector, write flash. So we're going to basically go through these functions, right, and translate to our new code. So, what does this random read do? We're going to read 256 bytes. That's cool. Erase sector, write sector. Right. Was there a quick way we could switch between different erase sizes? Here, sector size. Where does sector size come into play? So basically, when we write a flash, we're going to do the data of the length of data, sector size. That's a progress bar, and we're going to write that sector. Do sector size. And then the last of the data. So we go to write sector. We erase the sector, and then we have our stride when writing, and yeah, not a terribly fast stride. So first, let's go to erase sector. So erase sector. We have our command erase. Do we have a command here? Flash commands, right? So we need to add this guy to our flash command. So we're going to start doing erases. Yeah, that's better. Oh no, it's not as pretty. So we have our sector erase. And we have read, reset, device info, random read. We don't necessarily have these other functions. So first, we need to do a status clear. So let's go up to status clear and enable status clear. Status clear should only probably be done for writing. Again, ruining my pretty lineup. I guess being wordy is not too bad in the situations using it. And we wait for flash, not busy. This is important later when we do write sectors, not so much for the erase. We should be good to go. I don't know why that one exists like that. So, I think we should write a helper function and do quick reads. So we're doing all this work to do a command read. Because we want to do a command read function, which basically does all of this, but clears it out. Status clear. So we're writing the status. Right. So that's doing a read. So we can issue a command, we can read a command, and we can write a command. This is issuing command. So status clear is issue a command. Wait for busy's read command. And write enable is a issue command as well. So I said we try a read command, but we do it on the ID code first. Read command will, and we can try on the other one as well. Or we could just do yeah, we could do that. We do a send command. And send command is basically an array of a value to writes and length of values to read. And we issue the command first. Okay, I think I know what I want to do. We're gonna replace. That's gonna be good. We're gonna replace all of these with a single function, and it's basically going to repeat this, but so where is this? I'll have to write some things here. Why it's doing a full thing there. We should only do until that. But quick question, I want to look at a read command. So we're going to do an H313. I want to see how much we can read. H313. H13. 13H. Okay, How much can you read? Okay, so it just keeps going. I like this. I like this. So we're going to do issue command, have a sequence of writes and a sequence of reads. Okay. What's the write command? I think this would be an interesting issue command thing we can try out. So we're going to try def issue command, and it's going to be a self command, which is an array, and read back, which is normally going to equal 0. We're going to return 0 for now. And just one thing I want to check is what write command we're doing, and if we can do it like a really large write. We're only writing 100. Where is this used? Empty. Oh, it's used in your map. So let's look at 13 or 12H. I want to see how much we can write with 12H. So we can only write pages. So the last 9 bits are zeros. So that's 2 to the 9th, right? So we can do 512. So we're going to assume we do 512 bytes. Okay, so 512 bytes. So first, we're going to divide this into 2 sections. We're going to have a write command section and a read command section, and this will help clean up our code quite a bit. So we're basically going write commands sequence until full issue and start again. So like here, which I have a little better comments here, but we're writing the address, or writing a read, we give it the 5-bit address, we're enabling it, we're turning, what was it, CR? Control register, okay. We're having it turn on, we turn it off, we disenable it, we read the single bit that's inside because we only wrote 1 bit. Actually, yeah, we only wrote 1 bit in this situation. So we turn it on, we turn it off, it's still enabled. That's the important part. We clear it out. all things, and then we keep going until we're full. So the first thing we want to do here is we go, and this is until full, and then we want to probably enable chip enable. So like probably want to do this right quick, which is going to be the chip enable is turned on. So we're enabling the chip enable here. Then we want to do the FIFO until full, or until full, or end of sequence. So we need a counter, or we say command count equals 0. And we're going to say command count equals command count plus 1. And we're going to write or command count is equal to or greater than, only to equal to or greater than, in case you get stuck in a situation where you accidentally double count over. Length of command. And basically we're going to write here and okay, and then we're going to do command, oh my god, do this before the command count so the increment doesn't have an issue. Command, I guess we just do index instead. That just seems so much cleaner to me. Oh, there we go. Right, we go until it's full, or that. And then once we're out of this loop, we're going to start. And our start is basically going to be this. And we go until it's empty. Go until empty, right? We go until empty. TXE, and okay. We're going to stop. Empty RX. This is all garbage data before command or during command issue. Okay, and then we're going to do a giant while loop so we can do larger commands. So we just keep going until the command's done. Then we're going to read data. So we're going to have a basically a read index. And we haven't disabled the chip enable, so that's where this comes into play. We're going to write zeros for every value we want to do something with. So we're basically just shoving QSPI data into it. Is there a good example? So yeah, we go back to the 13H. So it doesn't care. So it's like, I don't care what's coming in. So we're just going to write zeros. So writing zeros. And we want to index, basically, you know, have that there. Okay, but we want to do read index. And we want read back here. And it'll be read back, or no, read index read index. No way to really do a valid. I'm not really doing any error checking here. Is there any error checking? That's one thing we're not really doing well, so I'm not doing an error checking on the software. Maybe in the future, if this has a reliability issue, we can look at doing that. But so far, no. Plus equals 1. We do plus equals 1 here because it makes my life so much easier. So then, so we're gonna write. We're gonna have the what we call it. What are we calling it? The return value, I guess. Yeah. So return value. Basically, we're then going to do this whole step again where we're going to start. We're going to start until tx is empty. And then we're going to stop. We're reading the Rx. We're going to read Rx. And yeah, we're appending it to the return value. And we're going to do a big while loop so we can do large reads. We basically said we could read until the end. And we're going to say read index is greater than our readback value. This is a big thing like that. And the only thing afterwards is we need to make sure that we're doing this at the very end. Turn off. Turn off ship enable. And this should kind of put the processor in a good place. So, and we want to return this. So basically what we're saying is I can I just did a comparison. Sorry, wrong hotkey. So we're going to do an issue command here. Issue command. And we're going to do and we're going to do a read ID. And we essentially should get the same thing as previously. Well, shall we see? I'm curious. This might make all my functions easier. I'm probably missing. Yeah, there we go. You don't like a read back. We don't have a colon there. Issue command is not defined. Oh, self.issue command. Command read ID. Pretty sure it's probably supposed to be like a self there, you know. Oh, that is a very good point. Oh. So an issue command, first thing we're going to do is get PCIe memory. Oh. List cannot be interpreted as an integer. I think I have to just like tuple. So list object cannot be integer. How did we pass arrays in here, right? We're just a pass data. Maybe we just have to specify it beforehand. This is why I am not the best at Python, but it's useful. So we'll just say command equals do this command. Is that sufficient for you? Oh, great. Python. Why are we interpreting it as a I want this to be a list. So Python list as parameter, passing a list as an argument. This is not what we're doing. Please help me. Why, oh why? Command. Let's see if we can figure out why. Click 10 there. Will you get angry at me? So, we made it in. So, what if we try to send it as a list? I'm trying to get you to take it as a list. List object cannot be Okay. What do we got here? I don't see that's helping us here. I'm not doing range. The custom command. Ugh. Is there a better explanation out there that can help us with this layer? Yeah, but I'm my list or Python um, list as parameter error. Um, hmm. Yeah. So, oh, I know. I'm an idiot. It's not about the inputs, it's about the outputs. It's not saying my function's the issue. What it's saying is the hex function is expecting a value. And this is where I'm not a very smart person. Sorry for that. Command. Oh, one too many brackets. Out of range. So what I say is we don't do that. Let's just, at what we got. So that's a fun issue. We're getting nothing out. I bet. Okay, 10. Do we get anything different? So our readback is not working. I mean, it could be working for all I know. Because we should be getting a value no matter what. So we're not even getting into this register. Let me see, the REXC, TXC, wow, command is less. 4. Need to be and. These both have to be true. Oh. This is why. So. Sometimes it's best not to ask questions. So while both of these are true, we do this. While this is true and this is true. So if either of those is upset, we exit the loop. Right? Thinking about this right? Well, and we haven't broken a thing. So um So when we read ID, oh, multiple of these. 1, 2, 3, 4, 5, 6. Okay, let's go look at read ID real quick. Apparently I'm not sure how to do that. So we're looking at 90H. So to documentation then, 90H. 90H, please. Getting closer. Getting something I'm happy about. $24 bits of H. 24-bit bytes. 32 in total. Get 117. So that's true. We're reading this correctly. We want to read 2 after going 0, 0, 0, 0 on 24. Right? Those were the instructions we got. So that's nice. And then we want to do like x of all of this, but we want to do that index. And also, I'll keep these later. For now, needed. Okay. Not be interpreted as an integer. Right. Yeah, that needs to go inside. Okay. So now let's try to replace all our commands with issue commands. So we have this fancy read ID code. We're gonna be like, nah. I'm gonna say command equals. I left the command there. Zero, comma, 0, comma, 0, right? Return value equals. We're going to issue command, and it's going to be command. We're going to read 2 because that's what we're supposed to read of that thing, and we're returning that one. We do this. Command, because we need a self there because we're selfish. Okay, hopefully this works. Yes. So we now replace this command. So basically, this command we have a single value and we have 51. So let's try that. And we want to read 51, or hex 51. I mean, it doesn't really matter how much we want to read, but we're going to read 51. That 51 right there real quick. Turn value. And let's see if this gives us the same data. Yes. So we're now condensing all these really fancy commands into simple things. So we're going to do a read command. And we're going to keep this, that right there, the address, big Indianness. And we're just going to say command.append. Command.append that. And return value with this length right here. Okay, now let's see if that works. And then we have our support hardware do everything else. Okay, cool. We can go ahead and that. So we've created this really beautiful issue command that should allow us to do all our SPI functions relatively easy. Now we're going to, what's our first function? Now on to actually what we were planning to do the entire time, which is we're going to do a write enable. When you do a status clear, but to do status clear, we need to wait for flash not busy. Wait. Is not busy. I really like that. It just looks really easy for me to read. I don't really like the camel case. Self, right? Self is not busy. And this command is, we're going to be doing the is ready, or the status register mask, right? Status register mask. Status read. And yeah, that's all we're doing. Status read. So we're going to issue a command, and it's going to be a blank one, and we're going to it's a right. So if we'll do it like the proper way, so we're just going to do the first read value, bitwise and it, do the mask, and then say is it equal to mask. This is ready, is not busy. We should maybe do is busy, but whatever. So we're gonna return true, true, else return false. And what if we do this? We're just going to print self is not busy. Isn't it funny looking? SR is right. Oh, yeah. I don't really like all this self things. I mean, it does help you understand. So let's go check this out. To this, so we're going to do what? 05H. So yeah, let's go find this one. Oh, so we can just keep reading it. Where are the bits? Anyone help me with the bits? 0, right, in progress. Oh, device is busy. Okay, so this is busy. So we're just gonna call it is busy. Makes more sense. Is busy. Is busy. Okay. Now, quick question. So we're next doing a status clear, And all we do is we're just issuing the command. We're not returning anything, but we're waiting for Flash, not busy. I guess we should just do this at the beginning of like write function, not a status clear. So yeah, so we're just going to do def status clear self, and we're just going to issue a command. So command is going to be status clear, and we're just going to say self.issue command, issue command, and let's just go ahead and say we're going to do a self.status clear method. So it's running fine. Okay, cool. We do the sector race, and then we do the thing that we're going to kill all of them. And we don't want to do that because then I have to reprogram all of them. So we got to get rid of the rescan. So going back here, no more rescanning. The rescanning is going to kill each device. We are doing the write enable now. Good question. Where is the do we have like a page bit here? Where is the page bit? So these are all fun. Oh, we did a page MCS. We read an MCS file. So yeah, let's go here. We parse the MCS file down here. Page MCS. There we go. Here's where we go. We read it, and we're doing fun parsing. So, before we do anything, let's go ahead and you want to say load MCS self, comma, path, right? Import 3. Put that up here. Doesn't need to be like that, just like that. Right. Byte array, page, this is going to be path. Remember, wanted to do that. For I in range 100, right? 100. Print x file b. Right, file b byte array. Oh, it's a byte array. Ah, we should just be able to. Yeah, be able to do that. So yeah, so we're just gonna do self.load MCS. We're gonna be like, oh, you should go up thing and do the page.mcs file, right? Yeah. May take a while, but I just want to make sure we can. Okay. Cool. So we have the load MCS file. Now we want to do def write enable self. And yeah. Oh, and the sector. We have to do sector. This determines sector size. 21. 21. Right. 21H. 8 determines 64, and 9 determines 256. So self.sector. So we're returning this value, right? So this is going to be n2 sector size, and this is if equals 8, right? Sector size is that size equals that, else and if we look at the thing, I'm pretty sure the 17s have the 9s. Yeah, the 17s have the 9s. And this is going to be 256. 56Ks. Yeah, 64K, 256K. We are good to go. And we can say print hex of self.sector size. Okay, I know there's an issue here. Right, enable, we're just doing this. Nasty. Command. The right enable command. At 6. Okay, so 6 is the right enable command. We'll put that right after this one. Status register. Enable. Okay, cool. So we got the command right enable set. There we go. Okay. Only knows for each one. It's not particularly the smartest thing. So I guess we're just going to have to do def write. I'm just going to do write flash. Sure. Write flash, right? It sounds good enough, self-explanatory enough. And it's going to be address and data. And we're just going to kind of and then do these functions. Sound good? I hope so. See if we can get that done in the next 20-ish minutes. So, this is saying we're going from 0 to data, and sector size is how we're skipping. But it's going to be self.sector size, no big capital things. And this is going to be what, like, self.right sector. Delete. Sector size isn't really known per se, but you get the idea here. And self.verify sector. Okay. We don't need that. WD is just passing a pointer along. Self dot right sector. Right sector. Okay, and self dot verify sector. Just saying if it's not, we'll just go in. And this will be calling. We should be saying, oh, we want to do a write flash at 0 with file _b. Please. Self dot write flash. Oh, we still want that. Self dot write flash. 0 comma file _b. So now we want to define write flash. And what is this going to be? Like self, address, and data. So right sector. It's a pretty simple thing, it looks like. I know. So this can be a self erase sector. And so we shouldn't really worry about the reads. It's only after a flash. Erase sector. At the end of erase sector, we basically will do a wait address and a page write is up to 250 is up to 512. Please help me, just so I don't screw up. 200. Do a stride of 200. And we should just be able to read, and we should just read the entire sector. Just do a random read of the entire sector when we do that. And what this was a random read, this is going to be so random write. And why is the stride not used there? Really? No magic numbers here. Okay, so write flash. This is not write flash, this is write sector. Write the sector, we have to erase the sector. And the first command to fill out is going to be def erase sector self address. Cool. Erase sector. Basically, so we want to do those functions and erase sector and address like we would the other thing, and then do the function, and then we're going to wait until flash is not busy. Okay, so which is just going to be, right, it's going to be self status clear self dot write enable, and while not self is busy pass. And then we're going to do the random read kind of instructions, right? Oh. So here, but it's going to be not picking it up, but we're gonna have sector race BC. So do a sector race command 0. Once that's done, we're going to probably just do status clear. So you just want me to like do this again and then do a status clear on that. So is busy. Let me see. Let me look at that busy signal again. What was that? It was 058, right? Is the RDSR. Where is that register defined? After. Please. No. Tell me the bits inside the register. Why is it so hard to find the bits inside the register? Write in progress. Okay. A write register program erase others in progress. So, if that's true, we should just wait until it's done. Wait until done before moving on. Make sure nothing is happening. Okay, so that's our erase sector. So now we need to do a random write. Random read, page program write. Same basic setup there, so we probably copy that. And all we're doing is we're going to do program write 12, and we're adding the address and the bytes to be written and data. I think I can just append the entire data to it. And that should be good. Can append a list to a list in Python. So let's see. And okay, what is extend? Okay, so we want to call extend then data. So extend is what we want. So yeah, we're gonna do this. And call it random write. So I'm taking data. And then we just say, hey, we got the address down, guys, so why don't we just, extend with the data? Yeah, no. And instead of sector erase, we're going to do yeah, these commands are a little bit long. Oh well, I don't try to get this reprogrammed so that tomorrow I can focus on something fun. So we were going to random right, right there. Okay. Now we're gonna do verify. And in the verify, we can actually do a sector by sector. That's gonna be fun. Verify sector. So we're given the address and the data. And there is no stride. So we're doing self.read. We're going to do address plus address sector self sector size, because we can basically read the whole chip. That is what I was told, and we're going to be like, nah, we're just going to compare all of it in one go, and so. Okay, we're gonna go to main here. We're only doing one device. And before we begin, wrong here. We're gonna comment out this guy. And we're gonna do this read afterwards. I'll make sure I'm only doing one device. If we do multiple devices, it ain't gonna end well. Where was that? That was in self vector. That's gonna be in there right here. Okay, so let us see what happens. First off, is the verify sector is returning service in once? Okay, turns to one, we just immediately exit out. Nope, out of that. The uncomment that thing at the top is going to be. Okay. Oh, it's going to do nothing. So, my bad. We want to wait. I'm not doing good on these while loops today. Okay, so hopefully that should line up better. Oh, I is not defined. Line 207. I mean, I is not defined. Oh. Oh, we had a bad verify? It printed out the entire sector, did it not? So, what if we drop that straight down back to 80? And so let's. We don't want to print the entire thing for the verify. We want to print R byte and D byte. Huh? So we couldn't do. Interesting. Huh? Going good. Okay, so. Okay, so we're writing Flash. This is great. This means I can load my new flashes. I need to be able to verify the flash, and if not, program it. But we can do that later, just like a good old verify flash instead of. I just do a verify only. So let's try to do a verify only on the right flash. Verify only equals 0. If false. So we say if not verify only. Oh. Just go. I want to see how much that is. Good verify. We need to pass that down. Verify only. Verify only into the right flash. But I just want to see how much if we just do a verify only. So reading the flashes takes a bit of time. Okay, so next we want to try a larger stride. I just want to see if we do a larger stride that will improve the speed. I mean, we're doing read pretty fast, so it doesn't look like it's changing much. Okay, where we're doing the stride here. So I read the documentation. It said we should be able to do 512 on a what was that documentation? This is going to be the 12H. You told me I could do 512 bytes. Maybe the chips. No, the chip select doesn't change. This is me transferring the clock or not. Yeah, you say 512. Dude, the 24-bit address. Do 32-bit addressing actually. I do 32-bit addressing, and you say I can do 512 bytes. Okay. So let us try to write at 100, which I think we're currently doing. I don't think it's probably not going to speed up the write that much. I mean, the read already takes a good chunk of time. I kind of just want to kill him and be like, who cares? Okay. But I was told 200 is what we can do. I'll try to program the flash one more time, and that'll probably be it for the day. Look at this nice long stream. I'm wondering how many people care. Feel free to chat or say something. I'll say hello right here. Apparently I have to open this in web browser to chat. Say hi, chat, test. I wonder if this is on the recording, right? I think it's on the recording. Does that pop up in here? I don't see it per se. Oh wow, it took a while to come through. Yeah. Yeah, see it's right there. I wonder if I do a follower goal, does it what's it connect to? I wonder if I have to go play with that. Stream OBS. Yeah. Guess we can have interesting. Okay, so we did that. So let's see if the 200 fails again. That might have just been a bad. Oh, well, that's definitely gonna be slow. Let's see. You told me I could do 200. Can I do 200? I wonder why you won't let me do 200. And if I do, I have to do 100. Otherwise, I can't do 200. And it says address 0 is the issue, which is weird. Why is address 0 the issue? Reading a 48 instead of that. And I mean, we should be writing the exact same data. So the random write. All I can think of is that it loops back after the page. Oh, page size. Let's see if we can identify the page size in here. So that's going to be here, right? So let's go back to 21H. Okay. Line 20 is the page size. So let's do the page size then. So yeah. Okay, that's fine. And so page size. But this is gonna be 20. And 8 is 256. Page size. X100. Otherwise, the page size is X200. And this is page size, not sector size. Page size. And we're gonna put that into the stride, our magic stride right here. Now we're doing the page size, the appropriate page size, because we're actually only writing random writes that only do the size of a page, whatever the page is. So now we should be reading the device. Do that. Okay, so I have a new system I want to test out with new files. So, and then we're going to do, so tomorrow, I'm going to do another stream tomorrow just because I like developing in YouTube. These videos are, I think, much better referencing than watching live. So YouTube is just going to have a ton of videos of me streaming. And watch, comment. These are just to help, I guess, use documentation, identify, figure out how to program a flash on a device. Hopefully we've walked through the stages. I mean, this is more software development, FPGA development, but I feel it's critical because we can program the flash, we can upload new bit files to our FPGA, then do a rescan, and then be able to control how it works. Partial reconfiguration is another alternative, which is something we should look at later. That would be a fun side project when I have free time, is to partial reconfiguration over the ICAP through PCIe. So you create a design that has a large partial region, and then we could do like some basic math back and forth to see how it works. Okay, so that was some good development. Nice long video. I wonder how YouTube is going to take these things. Maybe I'll schedule the other one. I wonder how many people are going to watch and not what lengths they're going to watch. These videos, I understand, are absurdly long, but hopefully you can find some good use to them. Now, if I can just find my streaming service right here, we can end the stream. Okay, I guess see you tomorrow.